Hi, I'm Sheldon McDonald, and I'm doing some tutorials on assembly language programming. Um, I've been programming for assembly language for just over a year now, and I'm actually just finally pick up, starting to pick it up. Um, I found that the assembly language books are kind of scary to look at. Really, the best way to learn is through trial and error and just trying to use the commands and see how they work. My background has been completely basic my whole life. I started on the color computer 2 when I was 11 or 12. I learned BASIC, and BASIC had always stuck with me. When I moved over to IBM, I started using Quick Basic. When I moved over to Windows, I started using Dark Basic, and then Dark Basic Professional, and then App Game Kit. Those are all basic syntax programming languages. Um, yeah, so I feel that maybe learning assembly doesn't have to be scary. Maybe it just needs to be taught through the eyes of a beginner. um, so, in no way is my code going to be perfect. However, it's going to work. And it's going to work way faster than trying to do the same task in BASIC. So this first video, what we need to do is have a good working environment, a modern working environment. Programming on a color computer is not productive. You can try to use DiskEdTASM or the BASIC editor, and it's too slow. What we can do on a modern day computer, we can compile our code in less than a second. We can test our code in less than a minute, and it just makes managing files and everything so much easier. So what we're going to be using in my tutorials, we're going to be using some software that I wrote called RS-DOS Tool. So again, let's set up our environment. So let's go to smotion3d.net. You will find the latest rs-dos win.zip. You can download that, extract it, and you'll find this folder in there. So what we have in there is the latest release info, whatever I've been working on with it, and you'll find Lost Wizards assembler in the ASM folder. I've got his manual here, and I've also got his source files here with the GPL3 license. I've also had gotten permission to make sure that I was allowed to include that with my RS-DOS tool. I can't praise Lost Wizards assembler enough. It's extremely fast. Programming the same thing or trying to assemble something on DiskEdTASM could take 5 to 10 minutes just to find that you made an error, and then you got to fix it, and then restart the assembling process. What I have set up with Lost Wizards tool, we're debugging in literally like a second. So that's one of the tools we're going to be using is my RS-DOS disk tool. the other tool that you need to get is an emulator. I've got VCC downloaded. I've been told that there's better ones, but this is what I'm going to be using. Okay. The last thing, my RS-DOS tool needs a prerequisite. It needs DirectX 9. Some people on Facebook have been saying, oh, it's showing debug error or something. It's because you don't have DirectX 9 installed, okay? Plain and simple, that's all it needs, and it'll run. If it doesn't run, well, you didn't get DirectX 9. I've tested it on Windows 10 machines and it works fine. By installing DirectX 9, it doesn't overwrite the newer DirectX stuff. It just makes it compatible with the other stuff. If you can't get it to work, however, it will work on as old as, I think, Windows 98 2nd edition should actually work. Yes, it should work as long as it has like the last updates that Windows provided with it. Absolutely, it should work. To a little more modern, Windows XP is fine. Windows Vista is fine. Windows 7 is fine. Windows 7 is actually great. I think it's the greatest operating system that Microsoft has made to date. I personally like to stay a couple operating systems back because Microsoft doesn't know how to release a good product. It takes to the end of the product's life cycle till it's any good. Windows 7 has been good for me, and therefore I've stuck with it. Again, we're programming for a machine from the 80s anyway, so I mean, you should easily be able to find a machine that's compatible with my software. If not, you can still follow along with whatever you're using, but you will not be able to use the disk edtasm to follow along because there's some new commands with Lost Wizards assembler that we're going to take advantage of that is so much easier to use. And it doesn't even make any sense to actually program on a physical color computer. It's too slow. It's not productive. Okay, we can make it way more productive having the environment set up on a, on a modern day computer. Okay, so again, we got my RS-DOS tool. We got Lost Wizards manual there for his assembler. The GPL3 license, all that is there. Okay. We've got VCC installed, so we're good to go. Let's just go over the RS-DOS tool quick. We'll get our environment set up ready for our tutorials to start. So what you see here, I have 2 disk images that are in RAM. Okay, they're not actual physical disk images yet. You'd have to save the disk image first. Okay, any changes that you make here, moving files around, they didn't happen until you actually save it. Okay. The next tab over, we've got the the raw disk editor. So if we look at a disk right now, we'll look at track 17 sector 2. Should show us all the granules. We'll see that they're all free. They all got the 255 value. And when we look at the directory, it's all FFFFFF. It's empty. Okay. And it reflects that. It's empty. Okay. Then we have the program editor. This is really cool because we can type code in and save it to the disk image right now, right away. It's very fast. It's the reason why I built this tool. I found that there was nothing available to do what I wanted it to do. I wanted to be able to write BASIC in lowercase or uppercase and save it as binary BASIC. directly into the disk image file. I wanted to be able to write assembly code and assemble it before it even makes its way to an emulator or a color computer. I wanted a place to save my code, my subroutines that I whip up. This program is going to do all of that, which is awesome. Okay. So let's do a quick little test to make sure our environment is set up. So we're going to call this hello.bas. This is a basic program, so we'll go 10 print at 0 hello and hello. 20 a string equals INCI string. 30 if a string equals nothing, go to 20. 40 end, whatever. Okay, so this little loop here is going to check for a key press and infinitely loop if there's nothing and end. So I'm going to save this. I want you to take note that I have lowercase here and lowercase here. So when I save this and I look at it again, this is what my program has done. It has capitalized it for us, but it has preserved lowercase in quotations. Okay? I very specifically wanted it to be able to do that. Okay? If you don't want to use my editor, okay, you can use Notepad. We can create a text file. Let's go new text document, and we'll call that hello2. Okay. So now when we're editing this, I can do the same thing. I can say 10, print at 0 and hi. I can save it. Okay. And I can bring it into this disk image by saying add text. Now, when I add text, I want to just go over something quick. Okay, we're on the desktop here. We load this. It's asking if it's a basic program. Yes. Okay. So notice that when I click on this, it says ASCII. So that means it's human readable. This will still load in BASIC, but it loads slower, way slower. You don't want to load these files in that way. Too slow. We're going to be about fast. We're learning assembly. We want to do things faster. So I'm going to delete that file. Okay. We're going to load it as binary. Add binary. And I'm going to go down to hello2.txt. Is this a basic program? Yes. Does the file need to be converted to binary? Yes. If it was already a binary file, then no, you don't have to do that. But in this case, yes. So now, when I click on it, it's also a binary file. And if I want to see what that looks like, that's what it looks like. Okay? And it will load on the emulator. So let's set up our let's set up the emulator now to make sure that that's all working. So let's save the disk on the desktop. We'll save it as hello.disk. We got VCC here downloaded. I think I showed that, but if I didn't, it's here. You can find it in many places on Google. And then DirectX 9 can be found quite easily. Okay, so we have that. We're going to load it. So I have the 502 cartridge installed, and then I have the Hello disk already loaded. Okay, so if I go dir right now, it should say hello and hello2. So if I load hello and then type list, you can see that it preserved the lowercase hello, which is great. So when I run this, it works. Okay. You have to close the emulator down if you're going to modify the disk image, though. Okay. So let's add one more test program in here. Go to the program editor. This time we're going to save test.asm on disk 1. So we'll just make a quick little file here to test our environment out. With assembly language, tab is your friend. You have to make everything tab delimited for the assembler to not make any mistakes. Okay, so normally you would put your label first if there is one. Then you can tab and put the command in. So the first thing we're going to do is we're going to tell the assembler to originate at somewhere in memory. We're going to start at 3000. We're going to eventually have to look at a memory table to make sure that we're not conflicting with BASIC, that we're going to crash something. Okay, I'm going to make the label start. And it's also going to tell the compiler where the start of our code begins. And then we're going to use a ROM routine here. I'm going to say jump to subroutine JSR A000. Okay, so A000. This is the ROM routine called polecat. Okay, this ROM routine will check for a key press. Okay, now I want to compare those results. So what happens in that ROM routine is it checks for a key press and it returns the value to A. So we're going to look at the A register. So I'm going to LDA. No, I'm not LDAing. I'm comparing it. It's already loaded. So we're going to compare A to the number 0. Okay. Now, if it's equal, branch equal. That means that nothing was pressed. So we can branch equal to start. That is your assembly program right there, pretty much. We're just missing the end to the start. Oh my gosh, button sticking. That is your assembly language test program right there. There's a difference I want to do, though. I want it to return to BASIC instead of causing a soft reset. It might even be a hard reset. It's probably a hard reset. Maybe it's soft. I don't know. Again, I'm a beginner learner myself, but we're going to teach you assembly anyways. So this will return to BASIC. Okay, so we're going to save this. Now we've got test.asm. So let's test out Lost Wizard's assembler. You'll type lwasm. You'll see the arrow is pointing to this disk image. I've selected the file and I've hit assemble and assemble. Now it's done. Like I said, it assembles in less than a second. Here's our assembly code. If we made a mistake, let's say, oopsie, spelling error, saved. If I go to assemble it, the assembler will catch it, and it'll come up with an error, bad opcode. It tells me that the error happened on line 5, RTSS, return to BASIC. So it happened on that line. So when we return to RS-DOS tool, we can type 5 and hit go to error line. It highlights it and shows you where the problem is. We can correct it, save it, and reassemble it. So you can see that this is nice and quick. You won't get this kind of speed on programming on the actual color computer. You just won't. So now we can save our disk image to the desktop. Hello disk, save. Remember, VCC or the emulator you're using needs to be killed before you save the disk image, because the emulator will lock the file. So if we go dir, we should have 4 files on there now. I should be able to type load M, which is machine language code, test, enter. To run it, we'll type exec instead of run. So now what this code should do, it's very simple code. It's just checking for a key press. And if it equals 0, it's going to infinitely loop. So when I press enter here, it should act as if the computer froze. And that's what it looks like. But if I press a key, like I'm going to press the space key right now, it says OK. And it says OK because I've returned from subroutine. I've returned to BASIC. Because this wasn't in a subroutine, BASIC treats your execute as a subroutine. So if you're RTS, it'll return back to BASIC. Okay, so we're going to be doing a lot of testing the assembly language codes, and maybe we'll be peeking or poking around in memory to see what values we've changed and what's happened. Okay, so we can get a better understanding of how assembly works. Okay, so this was my first video, and again, this is just setting up your work environment. If you've got one set up already, you should still be able to follow along, but I think you'll be able to follow along a lot easier if you're just using my tool. Again, I'm not going to be teaching you the best way to do this stuff. I'm just going to be teaching you a way how to do this stuff. You know, through the eyes of a beginner, maybe I can teach you something that that an advanced user would not care to teach because their you know, their way of thinking is just way too advanced to explain it better. Anyways, if you've stuck around this long, you might want to check out my next videos. The next video will be talking about the processor, and then we'll be going into building actual functions that we can use that will emulate using functions from BASIC. And you know what, we might just start learning some assembly language, and like I said, it's way faster than BASIC. I don't even want to touch BASIC anymore on the color computer. I feel like I'm at that point where it's just too slow. Assembly is amazingly fast, and it's worth that little bit of a learning curve to jump to it, to make that jump. All right.